Day 12, Hot Springs. You've finally reached the hot springs. You can see steam rising from secluded areas attached to the primary ornate building. As you turn to enter, the researcher stops you. Wait, I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like the hot springs to you. Oh, sorry, common mistake. This is actually the onsen. The hot springs are next door. You look in the direction the researcher is pointing and suddenly notice the massive metal helixes towering overhead. This way. It only takes you a few more steps to reach the main gate of the massive fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry they're not very hot right now. We're having a lava shortage at the moment. You ask about the missing machine parts for Desert Island. Oh, all of Gear Island is currently offline. Nothing is being manufactured at the moment. Not until we get more lava to heat our forges and our hot springs. The springs aren't very springy unless they're hot. Say, could you go up and see why the lava stopped flowing? Springs are too cold for normal operation, but we should be able to find one springy enough to launch you up there. There's just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which springs would be safe to use. Worse yet, their condition records of which springs are damaged are also damaged. You'll need to help them repair the damaged records. In that giant field just outside, the springs are arranged into rows. For each row, the condition records show every spring and whether it's operational or damaged. This is the part of the condition records that is itself damaged. For some springs, it is simply unknown whether the spring is operational or damaged. However, the engineer that produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. This list always accounts for every damaged spring, and each number is the entire size of its contiguous group. Okay, this sounds complicated. How many different arrangements of operational and broken springs fit the given criteria in a row? Okay, so we're doing arrangements would imply permutations or combinations. So dot means it's working. This means it's damaged. Question mark means we don't know. This is a search problem, right? Okay, this gives me confidence. If they're not huge, then I think we can just do like recursion. We're gonna make a function called recurse. Let's call it descend, because it's gonna be me descending into madness. So we're gonna descend record sizes. Local record equals 1. Local sizes equals 2. We're gonna take the first size. We go sizes removed from the end, the longest comma star. Okay, that gives us the first number. And then what we're gonna do is when we descend, we're gonna go record and we're gonna remove the first comma. Uh-oh. Oh, we don't have a base case. If sizes, if it contains a comma, I think we can just do comma. Okay, 113. Okay, look at this. We have successfully recursioned. So now we need to find the possible records. So if we print out the record here, we can say, I don't know, size. So we're gonna do a regex. Okay, so I don't think we can do this with regular expression. All right, scratch that. This isn't gonna work though. I need to draw. So let's say we have this string, and we're looking for three things. So we get here. Oh, we actually can't get 3 things here. Let's add another one of these. So once we get to here, we are effectively stuck. Basically, you can think of this whole thing as like a sliding window, right? And these guys are rigid. These are the obsidian blocks, right? We can't move the obsidian blocks. So let's make this a Minecraft analogy, right? So we've got obsidian block. Okay. This is what we're working with. So these ones, if we have to pick 3 here, we can't move either way because these obsidian are in the way. But if we make another example where we have, dirt, obsidian, dirt, more dirt, we can pick two different ways. We can pick these three, or we can pick these three. Even if there was another dirt over here, we can't go that far because we get stuck on this obsidian block. We can't slide past that. I'm YouTuber brained now. Look, I have to have my visual aids. So basically what I'm trying to say here is that we've been doing it wrong the entire time, but I actually think this is really easy, and we've been just being a fool this whole time and overcomplicating it. Our general structure here is right. It's just this inner loop that's wrong. RIP all of this code. We're back to knowing how to do recursion. So let's take a slice. Slice equals record index size. Okay, those are all of the possible slices that you can make for the first step. If the len of the slice is less than size, we return. Great. Check if we hit obsidian. Great. So we have two options, right? It can be this or it can be this. But we need to do our look ahead to make sure that we have a dot or a question mark next. Basically, we need to make sure there's not a pound sign next before we consider this a valid slice. So we'll do a look ahead of if record index plus size 1. Let's just print this. Great. So we'll call this peak. If peak is not equal to this character, then we print out the slice. So now we're only getting one slice for this part, which is really good. So what we're gonna do now is we're gonna chop off everything from here, and we're gonna recurse. So we're gonna take this section of the string and we're gonna pass it here. I'll print you what we're gonna do exactly. We're gonna descend record index plus size, I think +1, and sizes and iter -1. Great. So the next step is we go down and we're saying 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, so now we have to match the 2 on this section. So let's actually just run it and see what it does. So this one forks 4 different ways because there's 4 different places you could place the 2, 1. You could put it here. You could put it here. You could put it here. That's 3. Wait, wait. Let's try this on a different input. I'm tired of this input. I think we've finally done it. Okay, what are the answers? 1, 4, 1, 1, 4, 10. 1, 84. Bad start. 84. What do you mean 84? We were a little tunnel visioned on one particular solution. All right, we have one worth working on now. I forgot to test on an input that has dots. Let's go. Oh boy. What do we want to do? We want to throw away dots at the beginning. If a slice starts with a dot, we continue. Okay, now we get 0 results, which doesn't seem correct. I couldn't find anywhere to place the 1. Oh, when we continue here, it doesn't increment our index. Oh, that's horrible. All right, we'll do this. Okay, 8. Still too many. There should be 2 different ways to do this one. Okay, we need to stop when the right side is equal to a dot. Bad substitution. How do we get just the last character? Space -1? Wait, why does space -1 do it? Whatever, don't question it. It's bash, and it will do however it pleases. Ooh, 4. 4 is right, I think. I think this is it. Ready? Watch this. Oh, thank God. Okay. We can do the sample. We finally got there. All right, this is going to work first try. Don't even worry about it. Let her rip. Sounds good to me. That seems kind of low. Shit. It is kind of low. So, okay. Maybe we have let's think about a edge case. Is there one where it's like all question marks or something? Okay, we do have one line that's all question marks. Should we try this? Ooh. What the fuck? Do we have another globbing issue? Oh no. Imagine using a language that has gloving issues. Oh no. Okay, so what were we getting before, just to confirm that this did something? This didn't actually change the output, but I have a feeling this is breaking something. Okay, so we were getting 7781. We turn on no glob. I bet that's the problem. No, still too low. Oh no, shit. 2 problems? That's unheard of. Do I get the same answer if I had dots before and after the lines? 4 and 3. Okay, this is an interesting case. You're telling me these dots shouldn't be changing the answer. Oh, what is going on here, actually? Okay, you've raised an interesting point. Let's say group is slice, but we're gonna take off as many dots as we can from both sides. Println 0 group. Oh, there we go. If group less than size, then continue. So 7809 versus 7038. Well, we have a lower number now. Thanks for that. But I think it's a more correct lower number. What other weird edge cases do we have? I don't know. Can you give a high-level overview of your solution? Yes. Recursion. Does that answer your question? So how did this get 0? Would this get 0 if there were 2 question marks here? Yeah, it still does. All right, you've raised an interesting point. This seems to be an undercounting problem. How am I handling this case? I guess I'm just not. That's a bigger number. Run it. Run it. Don't even look back. Just go. Just go. Fuck, now we're too high. I'm sad. I have to actually use my brain. Let's give it a try. I get 1. Should it be 1? There's no question marks. Oh. But it's not valid, you're saying? Oh, that's wild. Should this just say 0? If we still have stuff left when we get to here, this is an easy fix. Left equals record. Okay. So that should fix it. Did I break sample? No, sample still works. All right, let's see what we get for input. 7855. That's a new number in between. This is our new lower bound. That's gotta be it. Please. No. We're close enough that it's not giving us above below. I'm pretty stuck. Why aren't we hitting this case until... Oh, hold on. It's because this continue happens first? Are you kidding? Oh my goodness. That continue is overriding this return. It was a gross fix, but yeah, I didn't think about the implications of adding this. Does that fuck up anything else? No. Is this one a problem? No, because that's mutually exclusive with this one. Okay. God, this code is a mess. Jeez. All right. I mean, honestly, they just make these a little bit too easy. I think, you know, we'll fix it in post. We'll fix it in the edit in the YouTube video. We'll make it look like we did it in like 3 minutes. Now you probably thought that I wasn't gonna go on to part 2, and you know you're probably right. I should probably just go to bed. Psych. We're doing part 2. As you look out at the field of springs, you feel like there are way more springs than the condition record list. When you examine the records, you discover that they were actually folded up this whole time. To unfold the records, on each row, replace the list of spring conditions with 5 copies of itself, separated by question mark, and replace the list of contiguous groups of damaged springs with 5 copies of itself, separated by comma. Well, that's easy enough. Oh, it's thinking. I think that's going to be too slow. So we can either do more tree trimming somehow, or we can... Oh, hey, we got the right answer, actually. You just need some sort of caching on top of your current solution? Like a memoization? What would we memoize here? Oh, wait, could we? Yeah, that is interesting. If we've already seen the string before, well, the string and the remaining sizes. So what? Key equals record sizes? Still seems pretty slow. Okay, so one heuristic we could add would be if a branch that we're about to go down is like doesn't make financial sense. What do I mean by that? I mean, if there's like literally not enough question marks and hashtags to fill the remaining space, then we can give up. I don't know if that'll help us with this one because this one's pretty rough. That's an optimization for sure. So we go, if the budget is less than the cost, then we return. We get out of here. Budget equals record, and then how do we get the cost? Comma with plus. Okay, so we have a math string. How do we evaluate the math string? I don't think we can just put it into the arithmetic, but we can try. So that works? Oh boy, that's wild. Okay, didn't expect. Okay, so this budgeting optimization doesn't really help us for this case where we just have a boatload of question marks. What's an optimization we can make here? I don't get how we have so many cache hits. Like we're hitting the cache like a billion bajillion times. Wait, this check should be inside the loop. I meant to put this inside the loop. Hold on. Stand by. Remainder equals record index. We can move this outside the loop to save us some time, because that shouldn't change. That should stay constant. But here, if we don't have more... Okay, let's try this. Oh, wait, we don't want returns, do we? Oh my gosh, wait. There's another problem. We have returns. These should all be breaks so that we still cache. Oh my god. That runs a lot faster. Does it still get the right answer? It gets a answer. I don't know if that's the right answer. How do I know if that's the right answer? I think we're in. We're so back. I just had some mistakes that I thought I fixed earlier. Can we just rip it? Oops. Please. Please just work. Okay, maybe we're not ready for that. It returned. Oh, come on, let's go. Are we done? Please tell me we're done. Oh, goodness. Oh, God. Holy cow. That was a trip.